Okay, so let's see this chapter 4. Chapter 4 is permutation and combination. Okay, so permutation and combination, maybe you are wondering what is this. It is to find out how many ways to do something. Okay, so for example, we have permutation. Permutation is to find out how many ways to arrange something. Okay, so for example, you can see here, with permutation is related to multiplication rule. So that's why at the beginning we have multiplication rule. So they say if a certain event can occur in m ways, and another event can occur in n ways, then both events can occur in m times n ways. So what is this? I give you one example. Let's say they say if a certain event can occur in m ways. So let's say you go to school. That's the event. Go to school. So you can do it in two ways. Okay, so either by car or let's say you take a taxi. Two ways. Okay, now you back from school, and let's say you can also do it in let's say you can do it in three ways. Okay, you can come back by car, you can come back by taxi, or maybe you just walk. Okay, so three ways to do it. And now, according to the information here about multiplication rule, they say then both events can occur in m times n ways. So now you have to do two of these events. You have to go to school and you have to back from school. So you want to do two of these, then there are how many ways? 2 ways times 3 ways, then altogether 6 ways. So 2 times 3, 6 ways. So maybe you are wondering which way are the 6 ways over here. So let's say you can build a tree diagram like this. Okay, so you go to school, you can go by car, by taxi. You come back from school, then there are 3 ways: car, taxi, and walk. Car, taxi, and walk. So from here you can see 6 ways. The first way is go to school by car, go back from school by car. So this is the first way. Car, taxi, second way. Car, walk, the third way. Taxi, car, the fourth. Taxi, the fifth. Taxi, walk, the sixth. So altogether 6 ways. So that is why the multiplication rule works in that way. Okay, so let's see example here. Part A. Find each of the following. Find the number of ways to form a mixed double. So mixed double, you should know, one male and one female player. That is chosen from 6 male players and 4 female players. Okay, so you want to do 2 events. The first event, you choose a male player. There are 6 ways. Second event, you want to choose a female player, 4 ways. So multiplication rule, 6 times 4, 24. Okay, so 6 times 4, 24 ways to choose the mixed double. So it seems like kind of easy, right? Okay, now let's continue. Part B. Find the value of each of the following. Okay, so this is the starting of factorial. Okay, this symbol in English we call it exclamation mark, but in mathematics we call it factorial. So what is meant by factorial? You see n factorial. N factorial is n multiplied with n minus 1 multiplied with so on until 2 until 1. Okay, so example, let's say I have 3 factorial, 3 times 2 times 1. 4 factorial, 4 times 3 times 2 times 1, 24. So that is the idea of factorial. You keep multiply the integers until 1. Okay, so that is factorial. And of course, you can use calculator. Press the calculator, 7 factorial, 7 shift x factorial. So when you press this button, then the factorial will come out, and then you press equal, then you get 5040. So of course this one I leave it to you. Now let's see how we use factorial in our example here. Okay, now let's say we don't want to use calculator, we want to understand the idea. Okay, we don't want to use calculator. In exam you can use calculator, but here we just want to learn something. Okay, so 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. 7 factorial is 5040. Okay, part B, 12 factorial over 9 factorial. Okay, so you see this one is 12 times 11 times 10 times 9. Okay, so until here I need to use a shortcut. It is very tired to write all the way to 1, so I know that it is going to be 12 times 11 times 10 times 8 times 9 8 7 6 5 4 3 2 1. Okay, so I'm going to let the 9 8 7 6 5 4 3 2 1 to be 9 factorial. Okay, so that means 9 factorial. I don't want to write so many things. The reason that I put it as 9 factorial is because I can cut with the 9 factorial at the bottom. Cut. Then I have only 3 numbers that remain. 12 times 11 times 10, 1 3 2 0. So you can see we can expand a bit, and then the rest we keep it as factorial. It is fine to do like that. So if you don't want to write everything all the way until 1, which is kind of tiring, then you can do like this. So of course if you are hardworking enough, you can just expand all the way to 1. This one bottom also expand all the way to 1, then you can just count and you will get the same answer. Okay, so now why we want to learn factorial? Let's see the next part. It is related to permutation. So still remember, not just now I said permutation is how many ways to arrange something. Permutation. Okay, so you see the formula first. NPN equal to n factorial. NPR equal to n factorial n minus r factorial. So maybe you are wondering, okay, this P is what? This NR is what? Okay, so this is permutation. P is permutation. NPN means you have n object, you arrange n of them. You arrange all of them. Then the formula is n factorial. So if you have n objects, you arrange only some of them, and then the formula is different already. You are not arranging all of them, you are arranging some of them, and then the formula is n factorial over n minus r factorial. Okay, so just remember these two formula first. I will give you more details on permutation later. Okay, so NPN, n factorial, NPR, n factorial, n minus r factorial. Okay, let's see how we use it. 5p5. 5p5 equal to 5 factorial. So equal to 5 factorial. 5 factorial, 5, 4, 3, 2, 1. Multiply them. 20, 60, 120. Okay, so that is the answer. 5p3. 5p3, it is 5 factorial over 5 minus 3 factorial. 5 factorial over 2 factorial. Yeah, so you can use back the same way as here, as part B. The top one you expand a little bit until you can cut with the bottom one, then it is fine already. So you can do something like this. Something like this. 5, 4, 3, 2, 1. 2, 1, I leave it as 2 factorial. 2 factorial. Cut. Then I have only 3 numbers to multiply. 5 times 4 times 3, it is 60. 60, yeah? Okay, so these are the two formula of permutation. Okay, so now let's move on. We look at the next page. Okay, so the next page is the starting of the permutation, where we have to build up the skill in calculating by using the idea of permutation. So remember, permutation means arrange some objects. Okay, arrange. The keyword is arrange. You can see here, arrange is used here. Arrange. Okay, so find the number of ways to arrange all the following letters or digits. Okay, so you remember one thing, just now we learned NPN. NPN equal to n factorial. Just now we learned this formula. This formula means you are arranging all means n of them, okay? N, the objects. Arranging all the objects, or arranging n objects. Okay, so you have n object, you arrange n of them, something like that. Okay, now example, you have change 1, 2, 3, 4, 5, 6, 6 letters. 6 letters. Okay, you are arranging all the following letters. You are arranging 6 of these letters. So you can put 6p6, or you can put 6 factorial. So like this, you can put 6p6, you can put 6 factorial, then you count 6, 5, 4, 3, 2, 1, multiply them. Okay, so I check with calculator. 6 factorial is 720. 720. There are 720 ways to arrange change in different kind of arrangement. Okay, so one of the example is like you can put it as change, you can put it at let's say CHANEG, this is the second way. Then you can arrange it as AHCNEG and so on. How many ways altogether? 720 ways. So I'm not going to write down all of them. I just give you some examples only. You arrange all of them in all kind of ways. So altogether 720 ways. Okay, now let's see the next techniques involving permutation. Okay, so you can see part E here. Find the permutation for each of the following. Find the number of ways of arranging 5 children in a circle. So remember, when you want to arrange object in arrange n objects in a circle, the formula is n minus 1 factorial. Okay, so if you are going to arrange 5 children in a circle, so your n is 5 minus 1 factorial, so which is 5 minus 1 factorial, that is 4 factorial. 4 times 3 times 2 times 1, which is 24 ways. So that is the answer. So remember it in a circle. Okay, so n minus 1 ways. Okay, now let's move on. Determine the number of permutation of each of the following. Okay, let's see the example here. We are not going to arrange all the objects now, so we have to use NPR. I write the formula again. NPR equal to n factorial n minus r factorial. So what's the meaning of this? It means you have n objects, you arrange r objects. Okay, so you don't arrange all of them, you just arrange some of them. Okay, now we see the example here. Find the number of ways to arrange 5 persons that are chosen from 8 persons standing in a row. So you have 8 persons all together, you arrange 5 of them. So that is going to be 8p5, 8 factorial over 8 minus 5 factorial, 8 factorial over 3 factorial. The top one I arrange sum 6, 5, 4 until 3. I put 3 factorial so that I can cut with the bottom. Okay, so I cut the 3 factorial. 8, 7, 6, 5, 4, 6, 7, 2, 0. So you can see so many ways to do it. 6,720 ways to arrange 8 people. Arrange 5 people out of 8 people. Okay, so let's move on. We look at part G. Determine the number of permutation for arranging each given word or digit in a row. Okay, so now what we see here is we have the same digit. You see we have 4, 4, 4, 6, 6. They are repeating digits. So if you have repeating digits or identical objects, the formula is going to be like this. Okay, so if you have I give you the concept. The concept, you have n objects, out of them R objects are identical, S objects are identical, and so on. And then the formula is you take n factorial on top. The identical object you divide like this, r factorial, s factorial, and so on. Okay, identical objects you divide. This is the formula. Okay, now let's see example. Okay, you see how many of the objects are are there all together? So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 objects. So n equal to 8. So we put 8 factorial on top. That's the formula, right? N factorial. At the bottom, we put the identical objects. So you can see 3 of the 4 here, 2 of the 6s here. So we divide by 3 factorial followed by 2 factorial. 3 factorial because the 4 and 2 factorial because of the 2 6s. So you divide in that way. Then after that, okay, let's say this round I just press calculator. You can expand and cut one, but let's say since we can use calculator, we just go ahead with calculator. 8 factorial is 40 40320. 3 factorial is 6, 2 factorial is 2 by 1, which is 2. Okay, then divide 40320 divided by 12. 3360. Okay, so that is remember, this technique is used when we have identical objects. If we don't have identical objects, we just use NPN or n factorial. No need to divide. If we have identical objects, you have to divide like that. Okay, so let's move on. Okay, so on this part we have problem solving. Solve each of the following problems. Okay, now first you can see 4-digit numbers are formed 4-digit. Okay, that means you have from the digits 2, 3, 4, 5, 6, 7, 8. You have 1, 2, 3, 4, 5, 6, 7. You have 7 digits. You take 4 digits and arrange them. So that is the idea of NPR. This is NPR. Because we don't arrange all of them. NPR. Okay, NPR. How many of the numbers formed are odd numbers? Oh, there is another condition there. Must be odd numbers. Okay, so this one I explain it in this way. A number is odd. For example, 21 is odd because the last digit is odd. Again, 103 is odd because the last digit is odd. 4445 is odd because the last digit is odd. So from here you have to get the idea. A number is odd if the last digit is odd. As long as the last digit is odd, then it is an odd number. Okay, now they are looking for 4-digit number. So imagine 1, 2, 3, 4. The last one must be odd. That must be odd. To be odd, we can accept 3, 5, 7. 3, 5, 7. 3 or 5 or 7. For this situation, I can only take one of the odd number from these 3. So I call this 3P1. I have 3 odd numbers. I arrange one of the odd number at the last position. 3P1. 3 odd numbers, arrange one of the odd number at the last position. So that is 3P1. Okay, so now I use up one of the odd number already. And for the remaining, I can put them in front. For the front part, I can put any number except the odd number that was used. One of the odd number is used at the back. I cannot use that anymore, so I can use others numbers. So what are the others numbers? So you just think about it in this way. We have how many numbers? 1, 2, 3, 4, 5, 6, 7. We have 7 numbers. One of the odd numbers has been used. We still have 6. We still have 6 numbers to put in front, and that is going to be 6p3. 6p3. So 6p3, 6p3. Okay, now we use multiplication rule. Multiplication rule say that you want to do an event, there are so many ways, then you want to do another event, there are so many ways, then the total way is you multiply. So similarly, I want to put odd number here. This is my first event. I have these ways. I want to put any numbers here. I have these numbers of ways. Now all together, how many ways? Multiply. So multiply 6p3 times 3p1. 6p3 is, check with calculator lah, 6p3. If you are wondering how to press the p, right, so you can just press shift multiply, the p will come out. You press 6 first, then you press shift multiply, and then you press 3. The calculator screen will show 6p3, then you press equal, you get 120. So similarly, 3p1, you just press in the similar way, you will get 3, and then after that you will get final answer 360 ways. So 360 ways to arrange 4-digit odd numbers. Okay, now let's look at part B then. 4-digit number that are greater than 4500. Okay, so let's look at part B. Okay, I do it at the side here. Part B. In order to get number greater than 4500, I'm going to consider it in this way. So 4-digit, the first one is 4, the second one is 5, this one can be any numbers. Then it will be greater than 4500. Okay, so other than this, this one, if I put like this only, this is just 4,000 something only, 4,500 something only. I get 4,500 something. Okay, so other than this, there are let's say there are 4,600, 4,700, 4,800, and so on, right? So that has to be considered as well. Okay, so in that case, that means the second position I can put 5, 6, 7, 8. So as long as I put 5, 6, 7, 8, then it will be 4,000 something that is greater than 4,500. Okay, so I have separated into 3 situations. So the first position I must put 4, so that is going to be, I have 1 4 only, I arrange 1 over there. The second situation, 5, 6, 7, 8, right? So I have 4 numbers, I arrange 1 over there. Now after using 2 numbers, we have used 2 numbers for the first and second position. So we still have how many numbers remain, so we have to check here again. We have 1, 2, 3, 4, 5, 6 numbers all together. We use 2 numbers, we still have 4 numbers. 4 numbers, then you can put any 4 numbers that remain at the last 2 positions. So that is going to be 4p2. Let me check first. 1, 2, 3, 4, 5, 6, 7. Oh, 7. Count wrong already. 7 numbers. I have 7 numbers. After using 2 numbers, I still have 5 numbers. So out of these 5 numbers, I arrange 2 of them at the last 2 positions. So now I multiply them. Okay, I multiply them. So multiply them. Okay, so then you will get 1 times 4 times 1 times 4 times 20, you will get 80. But that is not the answer yet, because this is just 4,000 something. We settled 4,000 something already. How about 5,000 something, 6,000 something, 7,000 something, and 8,000 something? So we need to consider that also. Okay, now let's continue. 2, 3, 4. Okay, so we have done 4,000 something. 5,000 something, that is going to be easier. So as long as the first digit is 5, 6, 7, or 8, and then you will get the 5,000 something, 6,000 something, 7,000 something, and 8,000 something. So this is going to be 4p1. And the number at the back can be any numbers. Any numbers, as long as you take it from the available choices here. Okay, so but you remember something, 1 digit has been used. So you have 1, 2, 3, 4, 5, 6, 7. You have 7 digits. 1 digit has been used. You still have 6 digits. So we have 6 digits. We arrange 3 over here. So we call it 6p3. Use multiplication rule. And then 4p1 is 4. 6p3 is 120. And then you get 480. Okay, now 4,000 somethings, there are 80 ways. 5,000, 6,000, 7,000, 8,000 something, we have 480 ways. So all together we have 80 plus 480, which is 560 ways to arrange the numbers so that it is greater than 4,500. So it seems like this is more complicated. So exam question will be like this, around this. Okay, around this. So we see more example. Okay, let's say one more. Okay, one more example. Okay, so question 1, let's say. 5 cards are chosen to form a code. Find the number of codes formed are even numbers. Okay, so a number is an even number if the last digit is even. So for example, 1, 2, 3, 4, 5. Okay, let's say I do it here. 1, 2, 3, 4, 5. As long as the last digit is even, include 0, then it is an even number. So we can take 0, 2, 4, 8. So we have 1, 2, 3, 4. 4 acceptable choices. So 4p1, because we only need 1 number at the last position. Okay, 4p1. Okay, now after that, for the numbers in front, it can be any numbers. Any. except the one that has been used at the end. So imagine you have 1, 2, 3, 4, 5, 6. You have 6 numbers. One number has been used. So you still have 5 numbers. That is going to be 5p4. 5p4. Okay, so we multiply them. 5p4 times 4p1. So you get 480. 480, yeah? So that is the number of ways to get even numbers. So 480 ways. Okay, now let's continue. Part B. Number less than 40,000. Less than 40,000. Okay, so to be less than 40,000, at the meantime it's 4 digit. It's 4 digits. Sorry, 5 digits. Okay, so let's say I do it here. Part B. Okay, now the number of ways is going to be, let me see first. Okay, first you see the first digit is important. To be less than 40,000, the first digit can be 0, 1, 2. 0, 1, 2. Okay, so you have 3 choices. We call it 3p1. 3p1. So after that, the 4 digits that remain can be any number except the one that has been used in the first position. So you have 6 numbers altogether. 6 numbers altogether. So one has been used at the first position. So we still have a remaining of 5 numbers. And you put them in 4 positions. So we call this 5p4. Use multiplication rule. Then you will get 3. 5p4 is 120. Then you get 360. So this is the second part. Okay, now let's see part C. Consists of digit 7. Consists of digit 7. Okay, so part C. Consists of digit 7. Digit 7 is at which position? It doesn't really matter. Okay, so imagine we have 2, 3, 4, 5. 5 position. You can put 7 here. 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 So there are 5 ways to put 7. 5 ways. You can put 7 at the first, second, third, fourth, fifth positions. 5 ways. Okay, so there are 5 ways to do this first event. Multiplication rule I'm trying to do like this. 5 ways to put 7. Okay, then after you put 7, right, we still have remaining of 4 positions, and you can put any numbers. Any number in the remaining 4 positions. Multiplication rule. The first event is I want to put 7. The second event is I want to arrange the numbers in the remaining 4 positions. Okay, so first you think like this. I have 6 numbers altogether. I have 6 numbers. Okay, these are the 6 numbers. I use 7 already. I still have 5 numbers. I still have 5 numbers. I arrange 4 of them. Okay, I arrange 4 of them. So that's going to be 5p4. 5p4. 5 times 5p4, which is 5 times 120, which is 600. 600. Okay, so we have done 2 questions for problem solving. Okay, let's move on. Okay, move on. Now let's see combination. Combination. You know, this chapter is permutation and combination. Okay, so what is the difference between permutation and combination? You have to make yourself clear first. Permutation is arranging something. Order is important. Okay, so combination is choosing or selecting something. Order is not important. Okay, so let's say example. I want you to be clear about the difference first. Permutation, order is important, right? So let's say you have 1, 2, 3, 4, 5. Let's say example. You have 1, 2, 3, 4, 5. Okay, I put 5p2. 5p2. 5p2 means you have 5 numbers, you arrange 2 of them. I press calculator. 5p2. 20. Okay. I changed my example. 5p2, which is 20. I'm trying to list down all the numbers, So listing down 20 is too long already. Let's say I choose a smaller one. Okay. So I simplify my example to 1, 2, 3. I arrange only 1, 2, 3. I arrange 2 of them. Arrange 2 of them. Then that is going to be 3p2, which is 6. 6 is still okay. Okay, I don't want it to be too big because I want to show you 6 ways to arrange it. So 6 ways. So there are 1, 2, 1, 3, okay, 2, 3, 2, 1, 3, 1, 3, 2. So altogether 6 ways. 6 ways to arrange. So you can see 6 ways. Order is important. That means like for example 1, 2, the order is 1 first, 2 second. This is the order. 2, 1 is the opposite order. 2 first, 1 second. So order is important. That means which come first, which one comes second is important. That is order. Combination, right? Order is not important. Okay, let's say example. You have 1, 2, 3. You choose 2 of them. Then it is 3c2. 3c2, you can press calculator. The C is shift divide. Shift divide. That is C. Combination. If you press 3c2, your calculator will give you answer 3. That means there are 3 ways to choose 2 numbers from the 3 numbers. Okay, what are the 3 ways? So you can choose 1 and 2. You can choose 1 and 3. And you can choose 2 and 3. Only 3 ways. Maybe you are wondering, why 2, 1 is not counted? Because 2, 1 and 1, 2 are considered the same results, as order is not important. 1, 2, 2, 1 are considered the same result because 1 and 2 has been chosen. Which first, which second, it doesn't matter one, you know. So as long as you are choosing 1 and 2, then that is one result. 1, 3 is a result. Maybe you're wondering, how come 3, 1 is not acceptable? Because 3, 1, 1, 3 are considered the same result because we are choosing 1 and 3. We are choosing 1 and 3, it is equal with choosing 3 and 1, you know. So order is not important one. Which first, which second, it doesn't matter as long as what combination of number is chosen, and that is important. Okay, we just want to see which numbers are chosen. Okay, which order doesn't matter. Okay, who first, who second doesn't matter. So 2, 3, 3, 2 are considered the same result because again we don't care about the order. So only 3 ways. Okay, now let's see. Combinations. Okay, is a bit, is just a little bit of stuff only lah. Not as complicated as permutation just now. Okay, first you see the formula. NCR. If you are not pressing calculator, then you have to use this formula. N factorial R factorial N minus R factorial. So is it compulsory to memorize the formula? Actually yes, because sometimes they give you unknown. So you don't expect, oh, I use calculator all the time, I don't care about the factorial formula. Cannot because sometimes they ask unknown. So NPR, you can see just now, this is the formula. NCR, you can see one extra part, R factorial is there. Okay, so that's the difference. You can press calculator, for example 9C4, 9 shift NCR. NCR is, for my calculator, is above of divide. Shift divide, then 4, then press equal, then 126. 26 is found. Okay, now let's say I'm not pressing calculator, 9C4, I use formula. Okay, then it's going to be 9 factorial 4 factorial, the R is 4, 4 factorial 9 minus 4 factorial, which is 9 factorial 4 factorial 5 factorial. Okay, so if I expand it, 9, 8, 7, 6, then 5 factorial, 4 factorial, 4 factorial I expand, 4, 3, 2, 1, 5 factorial I don't want to expand because I want to cut with that. Okay, then I can count and get 1, 2, 6. Okay, now let's see example. Determine the number of combination of each of the following. Determine the number of ways to form a basketball team. Consisting of 5 players, which are chosen from 12 players. So the keyword is chosen. When you see chosen, then combination. After all, we have common sense here also. We want to choose basketball player, right? So who first, who second doesn't really matter. As long as you are chosen, then you can represent your school already, you know, for basketball competition, you know. So order is not important. Okay, so how to count? I have 12 players, I choose 5 players, 12C5. 12C5, use calculator, 792. Okay, so just like that. 792 ways to choose 5 players from 12 players. Okay, so this one settled. Okay, now let's move on. Problem solving. Problem solving, this is the last part. After that, finish already. Finish this chapter. Okay, so let's see problem solving. A prize which consists of 5 items chosen from 3 calculators, 6 novel, and a pen. Okay, so you have all these. You are going to choose find the number of ways to choose the price. Choose a price. Okay, so our price here consists of 5 items. Okay, so part A, no calculator are chosen. Okay, you see how we do it. We don't want to choose calculator. That means 3 calculator we choose 0. 3 calculator we choose 0. Then after that, we don't choose calculator, but novel and pen, they don't mention anything. We just add them up and choose 5. So novel, 6 novel plus 1 pen, altogether 7. 7 of these you choose 5. 7 C 5. So why we end up and choose? Because they don't mind as long as no calculator. So calculator is the only condition. That's why we count calculator in this way. Other than calculator, for the remaining we just total up and choose 5. So 7C5. So then you will get 1 times 21, which is 21 at the end, the final answer. Okay, part B. The pen must be chosen and at most 3 novels are chosen. So for this case, there are many possibilities. Okay, the pen must be chosen. 1 pen. At most 3 novels. At most 3 novels means 3 novels, 2 novels, 1 novels, or 0 novel. Okay, so 3 novel and calculator. We need 5 items, right? So now we have 4 items. So 1 calculator. Second possibilities, 1 pen, 2 novel, 2 calculator. 1 pen, 1 novel, 3 calculator. I can't take 0 novel here because 1 0 then supposed to be 4 calculator. I don't have 4 calculator, so I can't do the last situation. 1P0N is not possible because I don't have 4 calculator. I must have 5 items, right? So I have only 3 possible scenarios. So what to do is we count the combination for each of these. Okay, so 1 pen. I have 1 pen. I choose 1, so that is 1C1. 6 novel, choose 3. 3 calculator, choose 1. I multiply because this is multiplication rule. Do the 3 events. So 1C1, 6C3, 3C1. Okay, so get 60. The second one, 1C1, 6 novel, choose 2, 3 calculator, choose 2. Okay, then we count this. 6C2, 3C2, 45. Okay, 1C1, 6C1, 3C3. This is going to be 6 ways. Now total 111 ways. Sometimes some students may feel like when I should multiply and when I should plus, So you see what I did here is I multiply first, then I plus. So maybe you feel like, when should I plus? When should I multiply? So we have an idea here. So multiply is used when you're using the concept of and. Plus is used when you're using the concept of or. So for example, I can do this in 3 ways. The first way is 1 pen and 3 novel and 1 calculator. Or the second way, 1 pen and 3 novel and 2 novel and 2 calculator. So you see, when I say and, that means I have to times. So 1 pen, 3 novel, 1 calculator I times. And times. Now, or the second way. So that's why I plus with the second way. Or the third way. That's why I plus with the third way. So the idea of and or is there. So when it's and, you times. When it's or, you plus. Okay, so we finished already. We finished the whole chapters. Okay, so combination and permutation, finish. SPM practice at the back. A lot of SPM questions. Okay, so that's all for this chapter.